Let's look at question 5c, where we have to trace through an algorithm, and we've got some code written in Python, and it says state. So whenever you have a question like this with some code written out, don't read the algorithm first of all, just read the question. It says here's an example algorithm that searches a list. State, for 2 marks I think, the value of the variables first and last when line 13 is executed, and search list mid holds the value of David. Okay, so let's step through and see. Search list is a list that contains these strings, 1, 2, 3, 4, 5, 6, 7 strings. Sorry about the quality of the photo of the revision workbook. Name is equal to Josie, so we're assigning the value Josie to name. We're initializing, setting an initial value of name to Josie. I might want to do a trace table at this point, possibly writing down the value of each variable. I suppose that we could do that, couldn't we? We could say, ooh, that's not right with a highlighter, that would be silly. So name is going to store Josie. First is going to store 0. Ooh, horrible line drawing skills here. There we go. Last here is going to store length of search list -1. Okay, so len means find the length. We counted 7, didn't we? 1, 2, 3, 4, 5, 6, 7. And then 7 minus 1 is 6. There we go. Mid is 0. I'm going to run out of space, aren't I, for this trace table. And then found is false. Let's put it over here. Found is currently false. So I've just got to this bit so far. Okay, line 11. While first is less than or equal to last. Well, first is less than or equal to last. And not found. Found is false, so not found is true. So both that and that are true. So I'm going to move on. Line 12. Mid is first plus last, integer division 2. So first is 0, last is 6, add them together is 6. Integer division, which means round down, is 3. So mid is set to 3. Trace table just means you move on to a next line when a variable changes. Okay, so I'm now on line 13. If you're doing this in exam, don't highlight the lines because you can't rub them out. Just use your finger or use a pencil to point to where you are at the moment. Then we're saying if the search list at mid is equal to name. So mid is currently 3. So search list 3 means 0, 1, 2, 3. That's Maddie. So if Maddie is equal to name, so name is Josie. Is that equal to what we want? No. So found is true doesn't run because this Boolean expression is false. Else, so this does happen. So we're on line 16 now. If name is less than search list mid, so search list mid, we should probably put that in our trace table. We worked that out as being Maddie, didn't we? So if the name, that's Josie, is less than that, well, we'll have to compare them as strings. Which comes first in the alphabet, Josie or Maddie? A, B, C, D, E, F, G, H, I, J. So J comes before M. So that Boolean expression is true, which means we'll execute the next line. Last equals mid minus 1. Aha. So mid is 3, last is going to be 2. There we go. And then we go back round to evaluate the while condition again. So whilst first is less than or equal to last, well it is. 0 is less than or equal to 2. And not found, yet we haven't found it yet. So this Boolean expression evaluates to true. So we're going to execute the next line. Boolean just means true or false, remember. Mid is first plus last. So first is 0, last is 2. Add them together, we get 2. 2, integer division 2, means 2 divided by 2 rounded down, which is 1. So mid is now set to 1. Okay, next line. If search list mid is equal to name, so mid is 1, 0, 1. So we're now looking at Callum. If that value is equal to name, well, name is still Josie, so that's not what we want. So else. If name is less than search list mid, so if Josie comes before Callum in the alphabet, well, no, it doesn't actually. So else what? Else first equals mid plus 1. Well, what's mid? Mid is 1, so first is going to be set to 1 plus 1 is 2. Okay, so let's evaluate the list again. And I haven't got to this point yet, have I, with David? So let's evaluate this again. Evaluate just means work out. Right, while first is less than or equal to last. So first is equal to last, and not found is true, as in found is false. So I do need to go on to the next line. Mid is first plus last, not lad. So what's this? First plus last. 2 plus 2 is 4. 4, integer division 2, is 2. So mid is going to be 2. And then we can say, oops. Don't say oops. It's much easier for you. You can just put your finger on the line number. If search list mid is equal to name, so mid is 2. So that's 0, 1, 2. Well, this is what the question is asking us for. So I want to get to line 13 after this value. So if search list mid is equal to name, well, yes, it is. Or no, it's not. I'm looking at David as the mid value. The mid index is 2, 0, 1, 2. David, is that equal to Josie? No, it's not. So I'm not going to continue with the algorithm. It just says state the values of the variables first and last. First is 2. Last is 2. And then if we were going to continue, what happens? Well, I haven't found what I'm looking for. We haven't found Josie. So we can say if name is less than search list. So does J come before D in the alphabet? No. In that case, else what? Let's see. First is equal to mid plus 1. All right. First is equal to 2 plus 1, which is 3. Then let's go back to our while loop. Oops, that's supposed to be a highlighter. Come on. Right, is first less than or equal to last? No, it's not, because 3 is bigger than 2. It's not less than or equal to. So that is false. And if you have a false, a 0, as an input to an AND gate, doesn't matter what that is, this whole expression is now false. So that means we break out of the while loop, and we can go down here and we can say if not found, well, found is still false, so not found is true. So I'm going to say name, that's Josie, is not in our list. So it's just practice of stepping through an algorithm step by step. Top tips here, write a trace table, put your finger to trace through where you are, or a pencil or something like that. Read the question first, the whole of the question, before you go through the algorithm so you know what you're trying to find out.